Good morning, students. Today we will discuss the module 3 Fourier integral and transforms. In this module, we already discussed Fourier integral, Fourier sine integral, and Fourier cosine integral. Today we will mainly discuss Fourier sine transform. Fourier sine transform is represented as Fs of S. Fs of S. Definition of the Fourier sine transform. Let f of x be a function. Let f of x be a function. We have to find out the Fourier transform of the given function f of x. For that, first we multiply this function with the sin Sx. First we multiply this function f of x by sin Sx and integrate. After that, integrate within the limit 0 to infinity. Lower limit will be 0 and upper limit will be infinity. After integrating and applying the limit, multiply the result by root of 2 by pi. Then we get Fourier sine transform of the given function. Therefore, you should remember the formula. Fourier sine transform is represented as Fs of S. Fs of S is equal to root of 2 by pi. Root of 2 by pi into integral 0 to infinity f of x sin Sx dx. That is, given function is multiplied by sin Sx. Sin Sx and integrate within the limit 0 to infinity. Lower limit will be 0, upper limit will be infinity. Then multiply by root of 2 by pi. We get the Fourier sine transform of the given function. We can do one problem based on this Fourier sine transform. The problem: find Fourier sine transform of f of x is equal to 1 in the interval 0 to a. 0 x greater than a. Here we have to find out the Fourier sine transform of the given function. Then we can do the problem. First we write the formula. Okay, formula. This is the formula: root of 2 by pi 0 to infinity f of x sin Sx dx. Therefore, write the formula f of s. Fs of s is equal to, again we write the formula root of 2 by pi integral 0 to infinity f of x into sin Sx dx. That is, the function is multiplied by sin Sx. Integrate within the limit 0 to infinity. Then this can be written as root of 2 by pi integral 0 to infinity by the property of definite integral. 0 to infinity can be taken as 0 to a f of x sin Sx dx plus a to infinity f of x sin Sx dx. By the property of definite integral, we can split 0 to infinity as 0 to a f of x sin Sx dx plus integral a to infinity f of x sin Sx dx. Then we substitute the values. That is, root of 2 by pi integral 0 to a. In the limit 0 to a, in the problem, in the limit 0 to a, the function given it as 1. Substitute 1 into sin Sx dx. Sin Sx dx plus, in the limit a to infinity, x greater than a, the function given it as 0 into sin Sx dx. That is, root of 2 by pi into integral 0 to a sin Sx dx. The next part will be 0. Therefore, the problem reduces to 0 to infinity reduces to 0 to a. 0 to a, lower limit will be 0 and upper limit will be a. Then we integrate root of 2 by pi sin sx. When we integrate sin sx, we already discussed in the plus 2 level. Integral of sin sx is equal to minus cos sx divided by s, 0 to a. Then applying the limit. That is root of 2 by pi minus taken outside cos as minus lower limit will be 0 minus 1 divided by s. That is root of 2 by pi into 1 minus cos as by s. Then we get the result as Fourier sine transform of the given function. Fourier sine transform of the given function will be root of 2 by pi into 1 minus cos as by s. 1 minus cos as by s. This is the procedure for work out the given problem. So first we take the formula. The formula says that root of 2 by pi integral 0 to infinity f of x sin sx dx. Here the function is a discontinuous function. Function given it as 2 interval. We substitute the given conditions and integrate and applying the limit. Finally we get the result as root of 2 by pi into 1 minus cos as by s. This is the required result. Clear? Just look at the steps. This is the property of definite integral, integral 0 to a to infinity by the property of definite integral. The second part will be 0, then 0 to a sin sx, integrate. Just apply the formula for integral of sin sx, integral of sin sx minus cos sx by s, then applying the upper limit, cos as, applying the lower limit, cos 0, value of cos 0 is equal to 1, cos as minus 1 divided by s. Take minus inside the bracket, then we get root of 2 by pi into 1 minus cos as. This is the procedure to find out the Fourier sine transform of a given function. Then we can do another problem. The next problem says that, second problem, find Fourier sine transform of e raised to minus ax. Next question, find the Fourier sine transform of the function e raised to minus ax. Here, first we write the formula. Fourier sine transform. In every case, you should write the formula. Then formula will be automatically by heart. Fourier sine transform is equal to root of 2 by pi integral 0 to infinity f of x sin sx dx. Root of 2 by pi integral 0 to infinity f of x sin sx dx. Here the function, in this problem the function is given as e raised to minus ax. Therefore substituting here integral root of 2 by pi integral 0 to infinity e raised to minus ax sin sx dx. E raised to minus ax sin sx dx. Then we integrate these two functions and applying the limit, lower limit 0 and upper limit infinity. Here, in this case, we use a standard result in integration. That standard result says that integral e raised to ax sin bx dx. The formula is e raised to ax by a square plus b square a sin bx minus b cos bx. This is the standard result in the integration. You should remember this formula. When we applying this formula, we can easily find the integral. The formula says that integral e raised to ax sin bx dx. E raised to ax sin bx dx is equal to e raised to ax divided by a square plus b square. into a sin bx, a into sin bx minus b cos bx. When we applying that formula, we get root of 2 by pi, root of 2 by pi e raised to minus ax, e raised to minus ax divided by s square plus s square. We apply the formula, standard result in the integration, e raised to minus ax by a square plus s square minus a sin sx minus s cos sx, 0 to infinity. Therefore, here we use the standard result. By using the standard result, we can write the integral as e raised to minus ax by a square plus s square minus a sin sx minus s cos x. Integration part is over. Then we apply the upper limit and the lower limit. Then root of 2 by pi into 1 by s square plus s square. When we applying the upper limit, x put it as infinity. Then we get e raised to minus infinity. E raised to minus infinity taken as 0. E raised to minus infinity taken as 0. Therefore, the upper part will be 0. The upper part will be 0. Then we apply the lower limit. When we apply the lower limit, 1 into minus a into sin 0. Sin 0 is equal to 0 minus s into 1. Therefore, simplifying, we get root of 2 by pi 1 by s square plus s square s into s. Therefore, the final result will be root of 2 by pi into s by s square plus s square. This is the Fourier sine transform of the given function. Therefore, to find the Fourier sine transform of e raised to minus ax, you just look at the steps. First, you write the formula. The formula says that root of 2 by pi integral 0 to infinity f of x sin sx. You should write every time. Each and every problem write the formula. Then formula will automatically by heart. Root of 2 by pi integral 0 to infinity f of x sin sx. In this problem, the function given as e raised to minus ax. The function given as e raised to minus ax. Therefore, root of 2 by pi into integral 0 to infinity f of x is equal to e raised to minus ax into sin sx. E raised to minus ax into sin sx. Then next part is integrate. Integrate this case. To integrate this, we apply the standard result. The standard result in the integration. Integral e raised to ax sin bx dx. Integral e raised to ax sin bx dx is equal to e raised to ax by a square plus b square a sin bx minus b cos bx. A sin bx, a into sin bx minus b into cos bx. When we apply that formula, e raised to minus ax divided by a square plus s square, then bracket minus a into sin sx minus s into cos sx. Lower limit will be 0, upper limit will be infinity. The integration part is over. Then applying the upper limit and lower limit. When we applying the upper limit, e raised to minus infinity is equal to 0. Therefore, first upper part will be 0. When we applying the lower limit, 1 into minus a into 0 minus s into 1. Simplifying, you will get the result as root of 2 by pi into s by s square plus s square. This is the procedure to find the Fourier sine transform of the function e raised to minus ax. You just look at the steps. Please check the list. The first step, second step, third step. And apply the standard result. The standard result you should write in the paper. You should write in the answer paper. Then based on that result, we can easily write the integration result. Then we apply the limit. Then our result will be clear. That is the procedure. Okay. Then we can do next problem. Okay. I will clear. I think that you all of them understand this problem. Okay. Okay. Click. Next problem, find Fourier sine transform of f of x is equal to sin x 0 less than x less than a is equal to 0 x greater than a. X greater than a. Here again given it as a discontinuous function. In the interval 0 to a, the function given it as sin x. X greater than a, function given it as 0. Here we have to find out Fourier sine transform. Answer. First we write the formula. Fourier sine transform is equal to root of 2 by pi integral 0 to infinity f of x sine sx dx. Root of 2 by pi integral 0 to infinity f of x sine sx dx. Then we can apply the conditions. Root of 2 by pi integral 0 to infinity. Here f of x is 0 to infinity. The limit can be split into by the property of definite integral. By the property of definite integral, we can split the integral. Therefore, 0 to a f of x sine sx dx plus integral a to infinity f of x sine sx dx. Then root of 2 by pi integral 0 to a f of x equal to sin x into sin sx dx. Therefore, root of 2 by pi 0 to a, here the function is sin x into sin sx. In this case, we apply a trigonometric identity which we already discussed in the +1 level, and a trigonometric identity. That trigonometric identity says that 2 sin a sin b, 2 sin a sin b is equal to cos a minus b minus cos a plus b. In +2 level, you studied this formula, 2 sin a sin b. 2 sin a sin b is equal to cos a minus b minus cos a plus b. Cos a minus b minus cos a plus b. By using that formula, here take 1 by 2 into 2 sin x sin sx. Here there will be a 2, but here not 2. Therefore, dividing and multiplying by 2, then 2 will appear here. But 2 sin x sin sx. In the case of a, here x. In the case of b, here sx. Therefore, we can write it as root of 2 by pi into 1 by 2 integral 0 to a 2 sin x sin sx. We apply the trigonometrical identity. When we apply the trigonometrical identity, we get cos x minus sx minus cos x plus sx dx. When we apply the trigonometrical identity, here a is equal to x and b is equal to sx. But 2 sin a sin b, 2 sin a sin b can be written as cos a minus b minus cos a plus b. This is equal to root of 2 by pi into 1 by 2 integral 0 to a cos 1 minus s into x minus cos 1 plus s into x. That is, we take x outside. Here x minus sx. We take x outside, 1 minus s into x minus x plus sx, x outside, 1 plus s into x dx. Then next step, root of 2 by pi into 1 by 2 0 to cos 1 minus s into x integrate ചെയ്യാം. cos 1 minus s into x integrate. When we integrate cos 1 minus s into x, the result will be sin 1 minus s into x divided by 1 minus s. 1 minus s is the coefficient of x. 1 minus is the coefficient of x. Write the denominator. Therefore, sin 1 minus s into x by 1 minus s minus sin 1 plus s into x divided by 1 plus s. This is the integration part. Appo cos 1 minus x, apply the integral of cos x. Integral of cos x is equal to sin x. Here cos 1 minus s into x. Therefore, we write it as sin 1 minus s into x divided by 1 minus s minus cos 1 plus s into x, sin 1 plus s into x by 1 plus x. Then applying the limit, root of 2 by pi into 1 by 2, applying the upper limit. When we applying the upper limit, sin 1 minus s into a by 1 minus s minus sin 1 plus s into a by 1 plus s. When we applying the lower limit, what will happen? When we applying the lower limit, this will be 0, sin 0, 0. Again it will be 0. Therefore, the final result will be root of 2 by pi into 1 by 2 sin 1 minus s into a by 1 minus s minus sin 1 plus s into a by 1 plus s. This is the procedure to find the Fourier sine transform of a given function. This is, you just look at the steps. Here we apply the trigonometric identity. You should remember the trigonometric identity. We have 4 trigonometric identity. The first one is 2 sin a cos b, 2 cos a sin b, then 2 cos a cos b, 2 sin a sin b. Here we apply the formula 2 sin a sin b. 2 sin a sin b, the formula says that cos a minus b minus cos a plus b. 2 cos a cos b, cos a plus b plus cos a minus b. 2 cos a sin b, sin a plus b minus sin a minus b. 2 sin a cos b, sin a plus b plus sin a minus b. These are the 4 important trigonometric identity. 2 sin a cos b, sin a plus b plus sin a plus b minus sin a minus b. 2 cos a sin b, sin a plus b minus sin a minus b. 2 cos a cos b, cos a plus b plus cos a minus b. 2 sin a sin b, cos a minus b minus cos a plus b. Here we apply the formula, the last formula, that is 2 sin a sin b. 2 sin a sin b says that cos a minus b minus cos a plus b. We apply this formula. Here a is equal to x. Here a is equal to x and b is equal to sx. When we apply this formula, 2 sin x sin sx, cos x minus sx minus cos x plus sx. Then we integrate 1 by 1, cos x minus sx, cos 1 minus s into x, sin 1 minus s into x by 1 minus s. Then second part integrate sin 1 plus s into x by 1 plus s. Then applying the upper limit and the lower limit, you will get the result. You just look at the problem and watch the problem and write this problem 2 or 3 times. Then we clearly understand this and we can write the in exam. Okay, clear. This is the discontinuous function. Here we apply another trigonometrical identity. You should remember that trigonometrical identity. Trigonometrical identity 2 sin a sin b, so cos a minus b minus cos a plus b. After that we integrate. For applying the trigonometric identity, we multiplying and dividing by 2. Then this will be 2 sin x sin sx. Our standard result will be 2 sin a sin b. To bring 2 here, we multiplying and dividing by 2. 2 sin x sin sx. Then after integrating, the final result will be root of 2 by pi into 1 by 2 sine 1 minus s into a by 1 minus s minus sine 1 plus s into a by 1 plus s. This is the required result. This is the procedure for finding Fourier sine transform of a given function. Okay, I think that everybody will clear these three problems. Okay, thanks.